Alright guys, today we're going to look at the power of a product rule. The product rule of exponents told us that when we multiply like bases, we add our exponents. And the power rule says that if we have an exponent raised to another power, we have to multiply. So what we're going to do is we're going to look at each of these problems. If I notice in each of these problems I have a product rule happening. Product rule. X squared times x to the fourth, that's a product rule that tells me that when I multiply like bases, that I'm adding my exponents. So this should be x to the 2 plus 4 power, and I'm going to raise that to the second power. This becomes x to the 6th, and when I square x to the 6th, I end up with x to the 6 times 2 power, which is x to the 12th. If I had distributed before I did the product rule, if I distributed, I would have had x to the 4th times x to the 8th, and that still would have ended up being x to the 4 plus 8, which is 12. So either way you do it, whether you choose to distribute the power first or deal with the product first, is up to you. In the second example, I have 2 squared times 2 to the 3rd. The product rule tells me that when I multiply like bases, I need to add my exponents. This becomes 2 to the 2 plus 3 power, and I still have to square it. 2 to the 2 plus 3 power becomes 2 to the 5th. And when I square this, this becomes 2 to the 5 times 2 power, which is 2 to the power of 10. This may require a calculator, but 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128, times 2 is 256, times 2 is 512, times 2 is 1024. So 1024. In the third example, I have 3x squared times x to the 5th, all raised to the second power. I'm going to do this one by actually distributing first. Again, it doesn't really make a huge difference, but this gets me 3 squared times x to the 2 times 2 power times x to the 5 times 2 power. This is 3 squared is 9, x to the 4th times x to the 10th. And when I add those exponents, I get 9x to the 4 plus 10 power, which is x to the 14th. In the fourth example, I have this 5 out front, and it will not be affected by that exponent because it's outside of the parentheses. I'm going to go ahead and do my product rule inside first. So I have 5 times 3x to the 5 plus 6 power p, raised to the power of 3. All I did was rearrange. I put 3 out in front since it's the coefficient. I added my 5 and my 6, my exponents, and I left p on its own. So I have 5 times 3x to the 11th p raised to the power of 3. Now I'm going to distribute that exponent of 3 to the coefficient 3, to the exponent 11, and to p. This becomes 5 times 3 to the 3rd, x to the 33rd, p to the 3rd. So now I have 5 times 27, x to the 33rd, p to the 3rd. 5 times 27 is going to be 135, x to the 33rd, p to the 3rd. In my last problem, I have quite a bit going on. 4p squared x times 8p times negative 3x squared, all raised to the second power. Me personally, I'm going to multiply those three numbers first, 4, 8, and negative 3. 4 times 8 is 32, times 3 is 96, so negative 96. I have p and p squared and p, that's p to the third. And I have x and x squared, that's x to the third. And this is all being raised to the second power. If I distribute that second power, I have negative 96, it's being squared. I'm multiplying 3 times 2, that's 6, and again 3 times 2 is 6 one more time. I am actually going to go ahead and pull up a calculator for this one. 96 squared is 9,000. If I can get a pen, there we go. 9,216, p to the 6th, x to the 6th. The reason I put this negative inside parentheses is because I'm squaring all of negative 96, so the negative had to be included. If I didn't include it, my answer would be negative 9,216. Alright guys, that was the power of a product rule.